This series of videos was recorded in the context of the WISE at 5 conference. I gave a presentation at this meeting in February 2015, and I promised that I would post video versions of the demos, and this is the first one of that set. For this first example, let's go to the WISE image service. I'm a galactic astronomer, so I want to search on a galactic star-forming region, IC 1396. As I type it in, it's going to resolve the coordinates into something and echo back the coordinates here to make sure that it is what I want it to be. The default search type is fine. For the return image size, what I want to do is I want to get a 30 arc minute field of view. So what I should do is pick the units first. Note that as I change the units, it converts the number that's in the box. So let's change the units to arc minutes and put in 30 arc minutes. Return only the most centered image containing the target is exactly what I want. But this can be a little bit of a gotcha that I've tripped across more than once. If you ask it to return only the most centered image containing the target and select more than one image set, it will do exactly what you ask it to do, and it will give you the most centered image containing the target, even if it's from a post-cryo 2-band observation. So especially if you have that set to yes, I would recommend turning off all of the other image sets and just have one image set that you want. We want the Atlas images from all 4 bands. Search. So these are the results screen. Over here in the upper left, it has a window pane that has some overview information. It has the coverage of the tiles that I returned on an IRSA image in the background. The blue circle is the search target. It has a multicolor image created from the WISE images, and it has details about the image that is shown. Let's go back to the coverage map. Down here at the bottom, we have the 4 WISE images that I requested. By default, they're zoomed in. Let's see if I can select those images. See, by clicking on it, it turns orange, and I can zoom out to make sure that the image fills the frame. So now I've zoomed out, and the whole 30 arc minute image that I requested is there. Up here is a list of the images that it returned. I asked it for only the closest image set to my target, so I have just one image set. There's one row for each band, and they're all tied together by similar shades of gray to indicate that they're all part of that same image set. Now, let's go get a catalog. Go up to the Catalogs tab. By default, it pre-fills the cert with coordinates that match the region you've already searched. Of course, for project, let's pick WISE, and for category, let's pick the All-WISE database. Let's pick the All-WISE source catalog. In principle, you could set column restrictions at this point, but let's just go ahead and search. It's going to come back with 5,400 sources in this region, and it's going to overlay them on the images. This is already pretty powerful because if you click on the source in the image, it's highlighted in all 4 images and in the table and in the image over here. So you can interactively explore the image this way. But let's make a plot and see if we can do an even better investigation of what the sources are here. Up here in the upper right, you can choose to view the catalog as a table or as a plot. Let's click on plot. Let's make the plot as big as possible by clicking on the expand arrows. By default, it's come up with a right ascension declination plot, and there's 2 important things to note here. One is that it's plotted it strictly mathematically correctly such that right ascension is increasing to the right, which is the reverse of astronomical convention. But at this point, the computer doesn't know any better. The other thing to know is that the points here are different shapes and shades of gray. The tiny lightest gray points represent 1 row from the catalog, and if you let your mouse hover, there's a pop-up in the lower right that shows you the value underneath your cursor. The larger, darker points represent several rows from the catalog. This one represents 6 rows. Now, right ascension and declination is interesting to plot, but let's plot something more astrophysically interesting. Click on the gears to change what is plotted. Now, since I'm a galactic star formation person, I want to make a color magnitude diagram so that I can examine the brightest, reddest sources in this region. So for the x-axis of my plot, let's plot W1 M Pro minus W4 M Pro. 2 things to notice there. One is that it's trying to help me autocomplete with column names that actually appear in the catalog. The computer understandably doesn't know what to do if you type in a column name that doesn't actually appear in the catalog. If you can't remember the column names from the catalog, click on the calls link, and it brings up a pop-up that has a list of all of the columns from the catalog with a brief description of what they are. The other thing to notice is that I'm doing simple mathematical manipulations. I'm subtracting one column from another. This is very useful for making these kinds of exploratory plots. For the y-axis, let's type W1 M Pro. Now, by default, it's going to use a label and a unit that reflects what I've typed in. Let's change that and make that a little bit more human readable. That W1 M Pro is the WISE 1 profile fitted magnitude. So let's type in 3.4 minus 22, the WISE 4 profile fitted magnitude. And the units are magnitudes. For Y, let's type in 3.4 and the unit is magnitudes. Okay, apply. It comes back with a plot, but it's done it again strictly mathematically correctly such that the top of the plot is the faint things. Let's fake it out and plot minus W1, MPro, apply. So now this plot looks kind of like what I expect. If you're not familiar with these kinds of plots, the objects that have 0 color are most likely plain stars. Down here is where you start wandering into the galaxies. The bright red stars are likely to be the young stars in this region. So let's click to select. I can, if I want, zoom in, and note that the points have now changed to all be the same color black. Each one of these points now represents a single row from the catalog, and again, there's a pop-up in the lower right that shows the value of the point underneath my cursor. Let's go back to the previous plot and click and drag to select the bright red sources again. This time, let's filter. So it shows over in the upper left-hand corner that there is a filter applied. There's actually 4 filters applied, one from each direction of the rectangle that I drew in that parameter space. If I want to cancel the filters, I could click on that icon, but I don't want to cancel the filters. I want to investigate what these sources are in the image. Let's close that. You can see there's many fewer sources now overlaid on the image. That's because the catalog is filtered down, and only the filtered down sources are what's shown here. So the sources that are shown, that are highlighted here, are in fact the brightest, reddest sources in this region, and they're interactive just like the plot was before. So if I want to see what this bright red source is, I can click on it, and it's the guy that's right just barely on the field of view there. What about this one? It's the one that's right there. So lots of interactivity to explore. If you'd rather look at the plot as a table again, it does exactly the same thing. You can click on the sources and have it highlighted in the table, just as it was highlighted in the plot. Now this object, because it's more or less at the north ecliptic pole, has lots and lots of visits from WISE. So let's do another catalog search and see if we can investigate how this source at the very center changes with time. Let's click on the Catalogs tab again. This time, I don't want a polygon search. I want a cone search because this multi-epoch photometry table you can see is enormous. So rather than doing a large region, let's do just a very tiny region centered on that point. I still want the WISE project, I still want the All-WISE database, but I want the multi-epoch photometry table. Let's go search. It comes back with 52 epochs of observation of this source. Let's make a plot. So the default plot, again, is right ascension and declination because those are the first 2 columns that come out of the catalog. But this one is pretty boring because there's only one source there. Let's change what is plotted. For the x-axis, let's do MJD for the date. For the y-axis, let's do W1 MPro epoch. Apply. So there's all of the time series observations of this source. You can see that's early in the mission and that's later in the mission. Let's zoom in on this earliest visit. Maybe even just this part of the earliest visit. And there's how this source changes with time. Maybe we want to see where this epoch is, because remember it's plotting it mathematically correctly. So this is the brightest epoch of this campaign. So let's go back to the view. Let's go back to the table view. That epoch right there is the brightest epoch of that campaign. So there's lots of interactivity and ways to explore things that way.